Hi students, this is a video on section 4.3 which is about multiplying fractions. Multiplying fractions is actually easier than adding or subtracting fractions, and that's why we're covering this one first. Okay, so to multiply two fractions, you just multiply straight across and then simplify. Okay, so to multiply fractions, to multiply two fractions, multiply straight across, multiply straight across, then simplify. Okay, so to multiply two fractions, you multiply straight across, then you simplify. So let's do an example of this. It's actually pretty straightforward once you know how to do it. Okay, so example, multiply Okay, and for our first example, we're going to be doing 2 over 11 times 2 over 13. 2 over 11 times 2 over 13. Okay, so we have two fractions here, 2 elevenths and 2 thirteenths, and we're multiplying. And like I said, you just multiply straight across. So that does not mean you cross multiply. Don't get that confused. That's something else. Okay, so you multiply straight across, which means you can rewrite this as 2 times 2 on the top, and then 11 times 13 on the bottom. And then you look here, we don't have any common factors. So 11 and 13 don't have any common factors with 2 and 2. So that means we can't simplify it. So that means we just go ahead and multiply these out, and that'll be our answer. So on the top, we know that 2 times 2 is 4. And then on the bottom, what's 11 times 13? Well, you can always write it out or use a calculator. But 11 times 13, you can write that out vertically, or you could probably just use your calculator, would be easier, since it's not in your times tables. Gives you 143. 143. Okay, so our denominator is 143. Alright, and since we can't divide anything, we can't divide both 4 and 143 by a common factor, this is our answer. Okay, so there's two steps. The first step is multiply straight across, and then the second step was to simplify. This one was a pretty easy one though, because it didn't have any common factors, so there was nothing to simplify. Okay, so let's see another example. Okay, example number 2. Negative 3/4 times 5 over 9. Negative 3 over 4 times 5 over 9. So now remember, when you're multiplying or dividing, if you have just one minus, that means your answer is going to be negative. Okay, so this means our answer is going to be negative. If there was two minuses, they would cancel out, and our answer would be positive. But because there's just one, our answer is negative. And then we just put a minus in front of our answer, and then we multiply straight across. Okay, so on the top, we're going to have 3 times 5. And then on the bottom, we have 4 times 9. Now, some people like to actually multiply it all out before they simplify. However, I would recommend that you simplify before you multiply it out. Okay, so what I'm trying to say is, look at 9 and 3. Do 9 and 3 have any common factors? And the answer is yes, right? 3 goes into 3 and 3 goes into 9. So if we divide the top and the bottom by 3, that's a common factor. So we divide this one by 3 and we divide that one by 3. All right? And so what does that simplify to? Well, after we do that, we're going to have negative, well, 3 divided by 3 is 1 times 5 on the top. And then on the bottom, we have 4 times 9 divided by 3 is 3. Okay, so you should have negative 1 times 5 over 4 times 3. And notice when you do it this way, the multiplication is even easier, because on the top we know that 1 times 5 is 5. And then on the bottom, 4 times 3 is 12. And if there was anything more, if there were any more common factors, you would have to divide by them here. But since there aren't, this is already simplified. So our answer is going to be negative 5 over 12. Okay? So that's a little bit harder one because it had that extra step where we saw we had common factors and we had to divide the top and the bottom. And again, that's method 1 that we learned in the class. I'm going to keep teaching method 1, but method 2 would be where you multiply everything out and then you factor it into a factor tree, and then you cross out common factors. But most people prefer method 1, which is the one that we used here. Okay, so we're going to do some more examples. Okay, so example number 3. For example number 3, we have negative 7 halves times negative 2 over 17. Negative 7 over 2 times negative 2 over 17. So notice we actually have 2 minuses here. And remember, when you're multiplying or dividing and you have 2 minuses, they always cancel out and make a plus. So right off the bat, we can cancel out the 2 minuses, and that makes a plus. So we know our answer is going to be positive. All right? And then how do we multiply? We multiply straight across. So on the top, we're going to have 7 times 2, and then on the bottom, we're going to have 2 times 17. And again, I'd recommend that you go ahead and simplify in this step. So looking for common factors, we can see there's a 2 on the top and the bottom. So I'm going to divide the top and the bottom by 2. All right, so those are both going to become 1. So that's going to give us 7 times 1 on the top, and then 1 times 17 on the bottom. But any number times 1 is the number. So that means our answer is going to be 7 over 17. And once again, looking at 7 over 17, notice that there's no common factors. So that's how I know it's time to box it. Because there's no numbers that go in both 7 and 17. So 7 over 17, or 7/17 is our answer. Okay? And I want to do a lot of examples of this stuff because people do struggle with fractions. So it's good to see lots of examples. So the one we just did was example number 3. So now we're going to do example number 4. Okay, example number 4. For this one, we have 66x over 53 times 2 over 33. Okay, so we have 66x over 53 times 2 over 33. Now the only thing that's new here is we have bigger numbers. And also notice that we have an x. But the x is only in the numerator. So if the x is in the numerator, you don't move it. You don't move it anywhere. It just stays there in the numerator. Okay, so there's no minuses, so we just go ahead and multiply straight across. So multiplying straight across, on the top we're going to have 66x times 2. And then on the bottom, we're going to have 53 times 33. Okay, so 66x times 2 on the top, and 53 times 33 on the bottom. And then we're going to want to divide out by any common factors. So you might not know this right offhand, but 66 divided by 33 is 2. So in other words, we have a common factor here and here. So looking at the 66 and the 33, well, what's the biggest number that goes into both 66 and 33? Well, that would be 33. So we're going to divide the top and the bottom by 33. Okay? Because that's the greatest common factor for 66 and 33. Alright, so after we divide on the top, we know that 66 divided by 33 is actually just 2. So on the top we're going to have 2 times 2. And then on the bottom, we're going to have 53 times, well, 33 divided by 33 is just 1. So on the bottom we have 53 times 1. Okay? And then there's no other common factors here because 2 is an even number and 53 is an odd number. So that means 2 does not go into 53. Alright, so now we're just going to go ahead and multiply this out. So on the top, 2 times 2 is 4. And then on the bottom, 53 times 1 is 53. Now it's easy to forget something. I've been forgetting something in the last couple of steps. So take a look at the original problem. What are we missing? Uh-oh, I forgot to write in an x. So there's actually an x right there and an x right there in the numerator. And I got lazy and I stopped writing it. So that's not good. We need to actually don't forget about your x. So we have an x here and then an x over here. So I almost forget about it. It's easy to forget about it, but I just remembered, so we're good. Okay? So because there was an x in the original numerator, there needs to be an x in every single numerator, including your last one. Okay, so instead of our answer being 4 over 53, it's actually 4x over 53. Okay? Cool. So these can be tricky, so I'm going to do a lot of examples. So that was example number 4. The next one is example number 5. Example number 5 is 7a squared times 1 over 6. 7a squared times 1 over 6. Now actually the way they write this, it actually looks like the multiplication is in the middle, and then it looks like 7a squared is actually in the middle. But that's not correct. This 7a squared times 1 over 6, what this means is this is actually 7a squared over 1. So if they don't write the denominator for the 7a squared, it's automatically 1. Okay, so this is actually 7a squared over 1. So the denominator for something that's not a fraction is automatically 1. Okay, so if they don't write your denominator, it's automatically 1. All right, and then, but once you know that trick, then the rest of the problem is pretty easy. So how do we multiply fractions? Straight across. So multiplying straight across, on the top we get 7a squared times 1. And then on the bottom we get 1 times 6. Alright? And then there aren't really any common factors here, because 6 is 2 and 3, and 7 is just 7. Okay? So all we do is multiply it out, and then we get our answer, which is 7a squared over 6. 7a squared over 6. Okay. Now all the problems we've done so far haven't had multiple variables, but in this next problem we're going to have multiple variables. Okay, so problem number 6, example number 6. Here we actually have x to the 5 over y to the 6. X to the 5 over y to the 6 times y to the 3 over x to the 4. Okay, x to the 5 over y to the 6 times y to the 3 over x to the 4. So once again, even though we have a bunch of exponents, we still want to just multiply straight across. Okay? So we're going to multiply this straight across. So we're going to have x to the 5th times y cubed on the top. And then on the bottom, we're going to have y to the 6th times x to the 4th. Now, there's a couple ways you can do the rest of the problem. One way is, if you know about it, you can subtract the exponents. So you look for whatever one is the bigger exponent for that variable, and then you subtract the smaller exponent from the bigger exponent, wherever the bigger exponent was. And the other way is to write everything out. In other words, to write x to the 5th as x times x times x times x times x. I personally prefer subtracting the exponents though. But I'll do it both ways. So let me tell you method 1. So method 1 here is subtract the exponents and let me be a little more specific. So subtract the smaller exponent from the larger one, okay? Subtract the smaller exponent from the larger one wherever the larger exponent is. Okay, so you look for wherever the larger exponent is, and you subtract. So basically here, with the x's, you can only combine the same variable. So you got x to the 5th and x to the 4th. So looking at these, x to the 5th and x to the 4th, you subtract the smaller exponent from the larger one, and you do that wherever the larger exponent is. So the larger exponent's on the top. So on the top, we're actually going to have x to the 5 minus 4. X to the 5 minus 4. So we're subtracting the exponents, and we're doing that wherever the larger one was. So the larger exponent was in the numerator, so that's why we have x to the 5 minus 4 in the numerator. Okay, and now we do the same thing for the y's. Okay, so looking at y to the 6 and y to the 3, we know that 6 is bigger than 3, so we're going to subtract. We're going to do y to the 6 minus 3, but it's going to be on the bottom. Okay? So on the bottom here, we're going to have y to the 6 minus 3. So again, you subtract the smaller exponent from the larger one. So it's 6 minus 3, but it has to be wherever the larger exponent is. So here the larger exponent was 6, and that was on the bottom. So that's why we have y to the 6 minus 3 on the bottom. Okay? And it takes a long time to explain it in words, but once you get used to it, most people find this to be the easiest way to deal with exponents. Okay? Alright. So then, what do we do next? Well, we just subtract. So on the top, 5 minus 4 is 1. So on the top, we have x to the 1. And then on the bottom, 6 minus 3 is 3. So on the bottom, we have y to the 3. Okay? So we have x to the 1 over y cubed. And then remember that any number to the 1 is just that number. Okay, so we don't write it as x to the 1. We actually write it as just x. Okay, so our answer is x over y cubed. Alright, most people prefer method 1, but I know sometimes in the book they use method 2. But again, in method 1, you're just subtracting the exponents, and then you're subtracting it wherever the larger one is. Okay, so let me just do method 2 really quick, so that you know about it. Okay, so method 2 is you write exponents as repeated multiplication. Okay, so you write exponents as repeated multiplication. Then you cross out any common factors. Then cross out any common factors. And when I say common factors, I mean common factors on the top and the bottom. Now the problem with method 2 is it can be really hard if your exponents are bigger, but I will do it just for this one problem so you can see it. So for our repeated multiplication, that means instead of writing x to the 5th, we actually write x times x times x times x times x. And instead of writing y cubed, we write y times y times y. Okay, so let me do method 2 really quick. Okay, so with method 2, we're going to start with the x to the 5th. That means we have a total of 5 x's in the numerator. So in the numerator, we're going to have x times x times x times x times x. So 5 x's. And then also in the numerator, we have y cubed. So that's going to be a total of 3 y's. So that's going to be y times y times y. Okay? And then this is all over our denominator. Our denominator has y to the 6, so that's going to be a total of 6 y's. Alright, so we're going to have y times y times y times y times y times y. So as you can see, the problem with method 2 is it takes a long time to just write out all the factors. But we have a total of 6 y's because the exponent of y was 6. And then on the bottom right corner, we have to have 4 x's, since we have x to the 4. Okay, so down here, we have x times x times x times x. Okay, so that's method 2. Most people prefer subtracting the exponents, but I thought I'd cover it just in case. So what do we do now? Well, now we just cross out any common factors. So looking at the x's, we see there's 4 x's in common on the top and the bottom. So I can cross out 4 of the x's. Alright? And then there's 1 x left over. We can't cross this one out because there's not another x on the bottom. And then we do the same thing for the y's. So looking on the top and the bottom, we see there are 3 y's in common. So that means we can cross out 3 y's on the top and 3 y's on the bottom. Okay? And then after you do all that, you're left with your answer. So on the top, we just have x. Okay, so we just have x by itself. And then on the bottom, we have y times y times y, which is y to the 3rd power, or y cubed. Okay, so our answer is x over y to the 3rd power, or x over y cubed. So notice we got the same exact answer as we did with method 1, but it took a lot longer to do method 2 because we had to write out all of the x's and all the y's. Okay, and if you have a huge exponent like x to the 12, as you can imagine, it would be way easier to do method 1. So I recommend for most people that you just do method 1, but I thought I would do method 2 just on this first problem so we see how to do it. Okay, cool. So believe it or not, I'm going to actually be doing more examples because fractions are hard, and so it's good for you to see lots of examples. Okay, so that was example number 6. Next one is example number 7. So for example number 7, we have 0 times 7 over 3. Now if you paid attention to one of my previous lectures, you'll remember that 0 times any other number is just 0. Okay, so 0 times any number is 0. So regardless of the 7/3, we don't have to worry about the fraction, because what this means is this means 0 over 1 times 7 over 3. Okay, and the 0 is in the numerator, not in the denominator. So our answer is just going to be 0. Because if you multiply straight across, on the top you have 0 times 7, and then on the bottom you have 1 times 3. Okay, but on the top that gives us 0, and on the bottom we have 3. And remember, 0 divided by any other number is 0. Okay, so our answer is just 0. Okay? So that's actually probably the easiest problem on your homework, if you just know how to do it. Any number times 0 is 0, even a fraction. Okay, so let's take a look at example number 8. Example number 8 is negative 17y over 21. Negative 17y over 21 times 3 over 7y times 3 over 7y. Okay, so once again, we have fractions here. And how do you multiply fractions? Straight across. And notice there's only one minus, so our answer is going to be negative. Okay, so multiplying straight across, on the top, we're going to have 17y times 3. And then on the bottom, we're going to have 21 times 7y. Okay? So don't forget about your minus. I also put the minus out front because we have a minus there. Okay, so far we have negative 17y times 3 all over 21 times 7y. And then if you're using method 1 like I do, you want to divide the top and the bottom by any common factors. So notice we do have common factors here. In particular, we know that 3 goes into both 3 and 21. Okay, so we're going to divide the top and the bottom by 3, since that's a common factor there. Divide the top and the bottom by 3. Sorry, I'm having trouble with my pen right now. Okay, there we go. All right. So on the top right, 3 divided by 3 is 1. Okay, so we're going to have negative of 17y times 1 on the top. And then on the bottom, we know that 21 divided by 3 is 7. So on the bottom we have 7 times 7y. Okay? And then we can simplify this by, since there's no common factors, we're going to go ahead and multiply on the top and the bottom. So we're going to get on the top, we have negative 17y times 1. That's just going to be negative 17y. And then on the bottom, 7 times 7 is 49y. So we have 49y on the bottom. But then we're not completely done, because we still have a y on the top and the bottom. So you can either subtract the exponents, or you can cross out the y's. Here, method 2 is probably easier because there's a y on the top and a y on the bottom, so they just actually cancel out. So you can just cross out those y's. But if you did method 1, where you subtract the exponents, you would have y to the 1 minus 1, which is y to the 0, and any number to the 0 is 1. So either way, everything's going to cancel out for the y's, and there's not going to be any y's left over. Okay, so that's actually going to give us our answer, which is negative 17 over 49. Okay, negative 17 over 49. Okay, cool. All right, and if you have multiple fractions, if you have more than 2 fractions, you still multiply straight across. So in our next example, we're going to be multiplying 3 fractions instead of 2. Okay, so example number 9, we have 2 over 15 times 1 over 3 times 5 over 6. Okay, 2 over 15 times 1 over 3 times 5 over 6. So if you have multiple fractions, you still multiply straight across. So multiplying straight across here, we're going to end up with 2 times 1 times 5 on the top. And then on the bottom, we're going to have 15 times 3 times 6. Now looking at these numbers, the only numbers here that have common factors are going to be the 5 and the 15. Because 5 goes into 5 and 5 also goes into 15. Alright, so we're going to divide the 5 and the 15 by a common factor. So we're going to divide each of those by 5. Alright, and then after we do that, what are we left with? Well, on the top we have 2 times 1 times 1, right? Because 5 divided by 5 is 1. And then on the bottom, 15 divided by 5 is 3. So on the bottom we actually have 3 times 3 times 6. Okay? And then multiplying this stuff out, we don't have any other common factors, or do we? Uh-oh, I missed something. What did I miss? Well, I just noticed that this 2 and this 6 also have a common factor. But that's okay. Even though I missed it in the previous step, I can still simplify these. It's alright to do it in multiple steps. Sometimes you miss something. So I noticed that 2 and 6 are both divisible by 2. So I'm going to go ahead and divide the 2 on the top and the 6 on the bottom by 2. And technically I could have done that also in my first step if I wanted to, but I was kind of not paying attention and I missed it. So I'm doing it now. Okay, so on the top, 2 divided by 2 is 1. So on the top we have 1 times 1 times 1. And then on the bottom, we have 3 times 3 times, well, what's 6 divided by 2? Well, 6 divided by 2 is 3. Okay, so on the bottom we have 3 times 3 times 3. Okay, and now we don't have any common factors. Alright, so now we just go ahead and multiply everything out. So multiplying the top and the bottom, 1 times 1 times 1 is 1. And then on the bottom, 3 times 3 is 9, times 3 is 27. So our answer is actually going to be 1 over 27. Okay, 1 over 27. And there, notice I missed something early on. Like in this step, if you wanted to get it done quicker, I could have divided this by 2 and divided that by 2 back here. But because I missed it, I went ahead and did it over here. You're allowed to do that. If you miss something in the first step, you can always do it in the second step. But what matters is once I got to here, I can see there's no more common factors on the top and the bottom. So that's why I know to just go ahead and multiply it out, and that gives us our answer. Okay, cool. So that was example number 9. Now I just wanted to do one more example that was a hard example. So this is example number 10. So for this example, it's challenging because we have some exponents. Okay, so for this one we have parentheses negative 3 over 5, parentheses to the 5th power, okay, or as people say, the quantity negative 3/5, quantity to the 5th power, times 1 over 3. Okay, so the quantity negative 3/5, quantity to the 5th power, times 1 over 3. So this is definitely your hardest problem in your homework that actually has multiplying, because first of all we have this exponent, and then second of all it's a big exponent, and we also have a minus here. But remember that an exponent like this actually means that you multiply it times itself that many times. So because here the exponent is 5, that means we're going to have negative 3/5 times itself 5 times. Okay, so writing that out, we have negative 3/5 times negative 3/5. Wow, my writing's getting sloppy. Try that one more time. Negative 3/5 times negative 3/5 times negative 3/5, total of 5 times, times negative 3/5 times negative 3/5. Okay, there's a total of 5 of those. Why there's a total of 5 of them? Well, because the exponent is 5. So that appears 5 times. Because the exponent of the negative 3/5 was 5. And also notice each one has a negative because the original expression had a negative on the inside of the parentheses. So the exponent actually refers to both the negative and the 3/5. Okay, and then that's our negative 3/5, and then we also have times 1/3. Okay, so this is times 1/3. So there's a lot going on here, but what I would recommend doing first is you cancel out minuses in groups of 2. So remember that if you have 2 minuses, you can cross them out. So the first 2 cross out, the second 2 cross out, but this last minus here doesn't have anything to cross out with, so that means our answer is going to be negative. Alright, and then remember you just multiply everything straight across. So what's that going to look like here? Well, on the top we're going to have 3 times 3 times 3 times 3 times 3. So that's 3 to the 5th power on the top. We have a minus out front. And then on the bottom we have 5 times 5 times 5 times 5 times 5. So a total of 5 5s on the bottom. But then also notice on the bottom we have a 3, and on the top we also have a 1. So on the top we have times 1, and then on the bottom we have times 3. Okay, so we have negative of 3 times 3 times 3 times 3 times 3, a total of 5 of those, times 1, that came from our 1/3. And then on the bottom we have 5 times 5 times 5 times 5 times 5, so there's a total of 5 of those, and then times 3 on the bottom. Okay? And then we can go ahead and cancel out any common factors. So like here we have a 3 on the top and the bottom. So if we divide the top and the bottom by 3, then those are going to cancel out and just become 1. Okay, so after we do that, what do we end up with? Well, on the top we have negative 3 times 3 times 3 times 3 times 1 times 1, because 3 divided by 3 is 1. And then on the bottom we have 5 times 5 times 5 times 5 times 5, and then 3 divided by 3 is 1 on the bottom. Okay, and then you can multiply all this out, and the 3's are not that bad to multiply out, but the 5's are pretty hard to multiply out. So I would recommend that most of you use a calculator for this, and if you want to, you can just use whatever calculator comes on your computer. So for example, on the top, we can do 3 times 3 is 9, times 3 is 27, times 3 is 81, and then times 1 is still 81. So on the top, we're going to get 81. And you can also do that on a calculator, like I was just saying. So on your calculator, you can do 3 times 3 times 3 times 3, and that gives you 81. Okay, so we have negative 81 over, well, in the denominator, this would be a lot of work to write it out by hand. So again, I would recommend doing that on a calculator. So in the denominator, we have 5 times 5 times 5 times 5 times 5. So notice there's a total of 1, 2, 3, 4, 5 5s. That actually gives us 3,125. So that's going to be our denominator. So we have negative 81 over 3,125. All right? And we already checked for common factors, so that's actually our answer. There's no common factors there. And that's about as hard as it gets on your homework for multiplying. Okay, so we should be good for there.